Hello, this is Ahmed Rashid, visiting assistant professor in Delta State University. In this presentation, I'm going briefly to talk about static friction. First, what is the definition of friction? The frictional force is defined as a resistance force on an object tends to move under an external applying force. What does it mean? If we have a trash can like this and the applying force F along this direction, a resistance force will appear between the bottom of the trash can and the floor. This resistance force is called frictional force. And the frictional force is always opposite in direction to F. And if the frictional force is equal in magnitude, so that means the two forces will cancel out. And according to this diagram, we have F here is the applying force along on the x-axis and the frictional force along the y-axis. And this straight line shows that as the applying force increases, the frictional force increases too, until it reaches its maximum value, which is F is maximum. As we increase a little bit the force beyond this F is maximum, the object starts moving along its direction, and the frictional force in this case is called kinetic frictional force. And according to this diagram, it shows that the kinetic frictional force is always less than the maximum static frictional force. And this makes sense because it's harder to get an object to move from stationary than to keep it moving if it is moving already. And the reason is that the Fs maximum is always greater than the kinetic frictional force. So, why there is friction? So we can answer this question on two levels. One is the macroscopic level. If we have two objects one on top of each other, and if we look carefully here, we find that the two rough surfaces have peaks. And peak 1 from surface 1 blocks peak 2 from surface 2, and this causes a frictional force. And this causes friction in general. So the second level is the microscopic level. And if we look carefully to these contact points between each peak, we find the molecule from peak 1 and the molecules from peak 2 forms a chemical bond at these red dots. And these chemical bonds causes a friction on top of the physical blocking of the two peaks. So this is the explanation. Second is what is the magnitude of the static friction force. If we do simple experiment here, if we push on this surface, on this object, so there is a small frictional force between the two surfaces. And if we push on with a small force, the object starts moving along this direction. But if we push down with a large normal force, we find that we need more applying force to start the object moving. And the reason is that large frictional force has appeared between the two surfaces. So that means we can formalize this maximum static friction force in terms of the normal force times some constant of proportionality called the coefficient of static friction, which is mu s. So the kinetic frictional force in this case can be defined in the same way. And we have here a different coefficient is called the coefficient of kinetic friction. So since we have Fk is always less than F is the maximum, so we should expect mu k is less than mu s. How can we measure mu s? If we have the object like this on top of the surface, and we start making an angle with the horizontal, so this angle, and we are going to increase the angle until the object starts sliding down. Right before it slides down, we are going to stop and measure this angle and call it critical angle. If we draw the free body diagram for this experiment, so here we have the x-axis along this direction, y-axis along that direction, and we have weight, mg. So the angle here is the same as the angle here, so we can decompose this mg, one along a negative y, mg cosine theta, and one along positive x, mg sine theta, and this is the normal force along y. So since the object tends to move along this direction, the static friction force, it will be in opposite direction. Since there is no acceleration in this diagram, so the sum of the forces along x and y are the same, are 0. So the sum of the fx, as we said, we have fg sine theta minus fs equal to 0, and along y we have n minus mg cosine theta equal to 0. By solving these two equations, we can find that fs from the first equation is equal to mg sine theta, and if we substitute this mg from this equation, it comes with n divided by cosine theta. Sine theta divided by cosine theta is tan theta. So from this simple problem, we found that f maximum is equal to tan theta times n, and the definition is given in terms of mu s. So from these two equations, we can conclude that mu s is equal to tan theta. So the static coefficient, the coefficient of static friction, is given in terms of tan the critical angle, which is independent of the mass of this object, independent of which side did this object sit on. So this area of the object is larger than this area. So this is totally independent of which area, if this area is large or small. Okay? So mu s here just comes in terms of tan theta. If we solve a simple problem on the static friction, we have an object like this, and we have an applying force F, making an angle theta with the horizontal. And the question is that, does the block begin to slide, or does it remain stationary under the effect of this F? And what is the magnitude of the frictional force on the block? So in order to solve this problem, we have to draw first the diagram. So this is the x direction, and this is y. And if we decompose this force, so one component here is fx cosine theta, and another component is fy is f sine theta. And we have weight mg, we have normal force m, and we have friction force. So the question here, in order to answer this question, is does this fx equal to this fs? If they are equal, the object will remain stationary. But if this fx is greater than fs maximum, so that means the object will start moving. So the question turns out to be like this. Fx is greater than the maximum static frictional force, so that means the object here in this case is going to move. But if we have fx less than the maximum, so that means the object stay in its place. Okay? So in order to answer this question, we have to find fs maximum and fx. From this diagram, we find that fx is equal to f cosine theta, and we have here f is 12 newtons and the cosine 30, so this gives 10.39 Newton. So this is number one. Second, fs maximum is equal to mu s times normal force. Mu s here is 0.7, but we have to find the normal force. From this diagram, the normal force, so this is from the sum of fx equal to 0, and this is from the sum of fy equal to 0. We can find the normal force. So the normal force here is fy, which is equal to f sine theta plus mg. F here is 12 Newton, this is 30, m here is 8 kilogram, and g is 9.8 meter per second squared. After substituting these values and find n, I can plug it in this equation to find mu s times n. And with just simple, straightforward calculations, we can find that Fs is 59 something. So if we compare the two values, we have Fx, which is applying force, is 10, and we have Fs maximum is 59.08. So since we have this condition, Fs maximum is greater than Fx, so that means the object will remain stationary. And in this case, the stationary force here, stationary frictional force here is equal to Fx. So the maximum has not been reached yet. In this way, the object will remain stationary. Thank you.